Awesome. All right. Hello, my name is Mary. I am a STEM educator here at the Cosmosphere. Um, I have been here at the museum for about 2.5 years now. However, I was on the staff many moons ago, back in 2006 and 2007. So the Cosmosphere is a big part of me, a big part of my life, always has been ever since I was a little girl. I remember coming here in fifth grade before the blackbird was even here, so it's been a part of me for a very long time. I have always been into astronomy and space and science for as long as I can remember. And so today I want to talk a little bit about um, eclipses in general. Kind of my experience with eclipses, and then obviously kind of give you as many pointers and helpful tips as I can for the upcoming eclipse that is in 80 days. So we are at T minus 80 days for the next total solar eclipse. Um, the last total solar eclipse that we had here in the United States was back in August 21st, 2017. Did anybody here get to go see the actual total eclipse? Okay, quite a few of you. Okay. Did anybody at least see a partial eclipse? Did everybody at least try to go out and see that? Okay. Did anybody get what close enough to totality that they thought they were close enough and then they weren't, and then they were disappointed that they didn't actually get to see it? That happened to anybody? I say that because one of my best friends actually, a couple days before the eclipse, she's like, "Hey, I'm going to be at this spot. We're going to see about 98%." And I'm like, "Oh, no, 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 no. You need to go about 10 more miles north for you to actually see the total eclipse." So she was very thankful that I gave her that helpful information. Um, so during 2017, we had, it was dubbed the Great American Eclipse because it passed basically straight across the United States, gave us about, 2.5, 2 minutes, 40 seconds of totality. Stretched about 70 miles during the path of totality. So it was amazing. I'll kind of talk about my experience with that here shortly. So before that, the last total solar eclipse that we had here in the United States that touched any of the kind of inner 48 states was back in February of 1979. It kind of passed up through a few of the northern states. So that was before 2017. That was the last time. And before that, it was in 1918. So we don't get the opportunity to see a total solar eclipse very often here in the United States. Obviously, you can travel other places in the world to see them, but it's kind of rare here. So this is a map that shows different areas. This was actually from 1961 to 1980. So NASA is very good about providing a lot of this information. And at the very end, I do have a slide that has links to all of these things. So if you guys wanted to take a picture of it, then you'll have access to that information. So, what is an eclipse? That's the big question. I have learned that people get confused on what is actually happening to make an eclipse take place. But basically, an eclipse is going to be when there is partial or total blocking of some celestial object in front of another one. So when you have a total eclipse of the sun or the moon, one of those objects will pass in front of the other. So we have three main types of solar eclipses. We have a partial, which that is when just a little bit of the sun is going to be blocked by the moon. We have an annular eclipse, which is one that just happened a couple months ago here in the United States. And I'll kind of talk about that a little bit more here in just a moment. And obviously the beauty, the total solar eclipse that we will get to see here in the next couple months. And then obviously we have lunar eclipses. There are some upcoming lunar eclipses that happen, but they're cool. But solar eclipses are definitely the more amazing thing to get to see. So, like I said, the last partial solar eclipse that we had visible here in the United States was in 2014, so almost 10 years ago. The last annular we had was just a couple months ago. Did anybody get a chance to go? I know it was cloudy here. I was in New Mexico for it, so I had clear skies. But so that happened just a couple months ago, and the last total, like I mentioned, was back in 2017. So, like I said, there's an amazing website that you can go, and they have predicted eclipses for the next like 1,000 years or something like that. And so you're able to click on one and be able to see exactly where it's going to go, the times it's going to start, and all that jazz. So we'll talk a little bit more about that here in just a second. All right, so the difference between a solar eclipse and a lunar eclipse is basically where the moon is at. So during a total eclipse, the moon is going to be in between the sun and the earth, okay? Casting a shadow that's going to be on the surface of the earth. And for a lunar eclipse, the moon is on the opposite side. So the shadow of the earth is actually what is hitting the moon and giving us that beautiful lunar eclipse. So again, it just basically depends on where the moon is actually at. So whenever an eclipse happens, you have the sun, light shining, it's hitting the moon, and it creates two different types of shadows on the surface of the earth. One is called the penumbral, and that is going to be a very wide shadow. So that's where you would be to see a partial eclipse. If you are in what is known as the umbra, the full shadow, that is a little very narrow, tiny strip going across the globe where you would be to be able to see the total eclipse. So total eclipses are pretty rare, and you typically, unless you're lucky enough to live in the path of where it's happening, you'll probably have to travel to be able to go see it. So, and a lot of people will travel across the country, across the world to be able to go see them. So and I promise you, it's definitely worth it. Now, how do these actually happen? What's actually going on? So when you look at the sun and the moon in the sky, they roughly look to be about the same size. Okay. And it's kind of a coincidence, more or less. So the sun itself, or excuse me, the earth is orbiting around the earth. Okay. Every 365 days. Everybody learned that back in elementary school, I'm sure. However, when it orbits around the sun, it's not a complete perfect circle. Okay. So at times of the year, we're a little bit closer and a little bit farther away from the sun. But on average, we say it's about 93 million miles away we are 93 million miles away from the sun. And so that has a little bit to play with the whole thing in general. Now, if we were to look at the actual moon, the moon orbits the Earth every month. But however, it is also not a complete perfect circle. Okay, so at times, what we call apogee, which is the farthest distance, we're going to have, I totally had those backwards, didn't I? I put those around. Excuse me. Perigee, or it is the closest, is going to be about 225,000 miles, and then the farthest away, about 250,000 miles away. So again, not a complete perfect circle. Now, if you were to take the distance from the sun, about 93 million miles, and you divided it by the average distance of the sun, or excuse me, the moon, it's about 400 times closer to us. The moon is 400 times closer. Okay. Now, if we go back to this, and like here's our little animation of the moon going around the Earth. So like you can see it's not completely a perfect circle. It is a little bit farther away at times and a little bit closer to us. Okay. So if we were to go back, if I get that picture to come back up, and talk about the actual size of both of these, the sun, its diameter is about 865,000 miles wide. That's pretty big, okay? The moon, quite a bit smaller at about 2,159. So pretty big difference there. So this is obviously not to scale. To put it to scale, that's about as close as I could get. Otherwise, if I got it exactly, the moon would probably look like a little pixel on the screen and you wouldn't be able to see it. So this is pretty close on how we compare the actual moon to the Earth, excuse me, to the sun. So the sun is about 400 times farther away than the moon, and the moon is about 400 times smaller than the sun. So because of those two numbers, that is how it appears to be about the same size in the sky when we see it on a daily basis. So it's kind of a coincidence that that happened for us and that we get to see that here on Earth, making eclipses possible for us to see. That doesn't happen very much that we know of out there in space. Nothing else that I believe that we know of here in our solar system. The distance and the size is not the correct size to be able to see an actual eclipse. So we're pretty lucky to be able to witness that here on planet Earth, which is really, really cool. Okay, so the question is, the moon is always orbiting around the Earth. So why do we not see a solar eclipse every single month? Okay, well, the Earth and the sun are on a plane, so like a flat plane. But the moon is actually tilted just a little bit, about 5 degrees. So at times, the moon is a little bit too high, and sometimes the moon is a little bit too low for the shadow to be able to hit us here on the Earth. So it has to be at that exact right point. And whenever the moon crosses that particular line, it's called a node. And then that is when an eclipse can actually happen. Okay. So typically an eclipse will happen about twice a year, up to 5 times. However, because of the Earth rotating, like I said, we rarely get to see them here in the United States. So you have to travel somewhere else to be able to see it. So an annular eclipse, this is a little animation. NASA's very good about providing animations to be able to kind of understand what's actually going on. During an annular eclipse, the shadow, the distance of the moon is a little bit too far. So the shadow of the moon is still hitting the Earth, but the moon is going to appear just a little bit smaller in the sky than what it normally would because it's a little bit farther away. Okay, so this is actually a scale of the size of the Earth and the size of the moon. So it's obviously pretty small. And whenever you get to see an annular eclipse, which back in October, I was in New Mexico. I was just north of Roswell, New Mexico. So I got to go hang out with all the aliens in Roswell. If you've never been, I highly recommend it. It's the cheesiest thing in the world, but you gotta go experience it. It's fun. So we were just north of Roswell. We were pretty close. We were about, less than a mile away from the center point of where the eclipse was going to happen. And so I'm really bad about taking video of myself. I don't like doing that. So I don't have a lot of video of the day that it happened, but I do have a little snippet that I put together. And when eclipse happens, and you're either in totality or you're in the middle of it, your brain just kind of stops functioning and you forget what you're doing. And so you kind of see that here. So again, this is a video of myself. It's not very long, but when annularity occurred. So, and there was a handful of people around us too, so you'll kind of hear them cheering in the background. So I'm shooting it through my telescope with my camera. You can tell it's still pretty bright outside. It is different, but we look at the side, the rain. We should okay, 100%. I'm crazy. Yeah, that's what we're looking at right now. So during an annular eclipse, like I mentioned there, we call it the ring of fire. because the moon is a little bit smaller in appearance. And so when it covers the sun, you get that little slither of the sun that still is visible. So that's why, even though we were in annularity, the eclipse was at the max, it's still really bright outside. Okay. And so we had our solar glasses, and then obviously I had a filter on my telescope to be able to safely view the sun. Otherwise, I'd probably burn my eyes up, and I don't want that to happen. And so we were surrounded by, there was probably, 100 people or so kind of surrounding us. So that was always the fun experience for me, is being surrounded by other people that are like-minded like us, to be able to experience. So it was a really fun experience. So I was taking a series of photos during the eclipse. It lasted about, I think that one was about 3 hours. And the annularity, so when it was at the max, it was about I totally forgot how many. It was a couple minutes long. So this is what I ended up with. So the picture on the left is going to be, that's our ring of fire, the moon with the covering the sun, and then my progression of my photos as the day went on. So there was a few clouds in the sky. That was about it. I know if you were trying to watch it here, it was, pretty much cloud cover here. So it was kind of a bummer that everybody here didn't get to see it. So I get that's the risk you have to take with eclipses. So, like I said, you had to go check out all the aliens. So here's some pictures of me. There's a museum there with all the aliens. So I had to share some of my alien pictures. Like I said, totally cheesy, but totally worth it. All right. So let's move on to the beauty, the total eclipse. So at this point now, whenever a total eclipse happens, the moon is at the perfect distance. And make sure that's moving. And so again, we get those two shadows, the umbra and the penumbral. And as it's orbiting around, you can notice just how it hits the Earth. Okay. And so again, you're going to be in that little slither that's going to go across the globe. So it kind of gives you a little bit of scale. Since the scale, we're pretty small in relation to just everything in general. So this is actually an image from a camera that's on a NASA satellite that is out in orbits about 1,000,000 miles away from the Earth, and it's called EPIC. And this camera typically takes a picture of the Earth about 12 times a day, every 2 hours or so. During the eclipse, the camera, they upped it, and so it took pictures more often to be able to capture the shadow going across the United States. So as it's rotating, you can see that shadow kind of swooshing across the United States. So it's just amazing that we have that capability of capturing that from space. So I've always thought that was really cool to be able to see. Now, this picture here is of a total eclipse. This is not a picture I took. This is actually a picture that my dad took back in 1979 during the eclipse before that. I don't know for sure where he was. My guess is that he was in Montana somewhere. I'm not sure. I have to, go back in time. This is a picture of me and my dad. My dad really got me into astronomy and science and stuff like that when I was a little girl. He took me to watch eclipses and lunar eclipses and comets and all that jazz. He actually passed away when I was 16. It was right after I got my telescope that I have. But he shaped me into being able to just love astronomy, love the skies, and to go out and chase them. And that's what I did. So I wanted to share that little picture there. So that for the 2017 eclipse, that was my goal, was to take a picture just like my dad had taken years before. So that was my number one goal. So for 2017, it was kind of an accident where we ended up. We were in this little bitty town in Wyoming called Glendo. Glendo has a population of about 200 people. So we were just north of where that arrow is where we ended up. It was kind of an accident. We drove by, noticed there was a bunch of people there, and they're like, oh yeah, we're letting people camp out in this field. There's porta potties, there's food, there's music. And we're like, it was $50. Let's do it. So we set up camp, and we were right next to the reservoir there, the national or the state park that they had. And they predicted, again, the population was about 200 people. They predicted that there was about 140,000 people within that area for the eclipse. So when I say it took us about 4 hours to get out of there afterwards, that's not a joke. There were so many people around there, but we were surrounded by so many people that were excited, and it was that helped make the experience as well. So we set up camp in the middle of the field. I had my picture of my dad and his picture of the eclipse on my telescope. And like I said, it was my goal to get that image. And so, again, I did not do a very good job at taking video that day. I tried, the video got messed up. So I actually found this video of some people that were in that exact same field. And I'm going to play it. And I want you to notice, one, how bright it looks right there before I even start the video. And so it's going to play, and then it'll kind of speed up a little bit. So let's kind of see and witness the eclipse. That was probably me in the background yelling. So the shadows are gone. It gets nice and dark. So this is going to speed up to kind of go through the whole totality part. When it starts back up, I want you to pay attention to the ground at their feet, and watch just how quickly the shadows come back as totality ends. So that was just in a matter of what, 10 seconds, give or take. So it happens very quickly. That eclipse was about, the totality lasted for 2 minutes, 27 seconds where I was at. And so it happened quick, but it was literally the best 2 minutes and 27 seconds I've ever experienced in my whole life. Now, no joke. So this is, again, it's hard to capture the true beauty of what you're seeing in the sky. It's just impossible to capture that. This is a video of an eclipse. This is not the 2017 eclipse. This is actually from 2019 of the total eclipse that went through South America. So a little bit of Chile and Argentina. But this is what you get to witness during a total eclipse. So you can see the shadow moving across the sky. When they say it looks like a black hole in the sky, it does. The sun feels absolutely enormous in the sky. Because at that point, we're able to see the sun in its entirety, the entire atmosphere of the sun, and it just feels humongous in the actual sky. So I guarantee you, I promise you, you'll want to go see it. So the day of, this is what I got. That was my progression of the eclipse. Everything was going great. The totality was moments away from happening. I'm like, okay, that's all I want to do is get that picture just like my dad. And I got it. Once I clicked it, I really don't remember what I said. I think I was like, oh my God, I got it. And everybody was screaming and yelling and cheering. And it was literally one of the best experiences I've ever had in my entire life. I've experienced cool things, but I definitely put the eclipse up at the top. So I was very proud of what I accomplished that day for sure. So let's talk about the upcoming eclipse, 2017. So this is the path that it is going to take across the United States. It kind of starts down in Mexico, up through Texas, the Midwest, up into the Northeast, up into Maine. Now, what I'm going to do, this is just a screenshot, but what I'm going to do is I'm actually going to click on this map here. And this is going to take us to this amazing website that is basically like Google Maps, but there's a French astronomer engineer guy. His name is Javier. I don't know how to pronounce his last name. He made this map not only for this eclipse, but for past eclipses and for ones coming up. So this is my go-to that I use whenever I am planning and trying to figure out what to do for the eclipse. So I'm just going to close the little box that's here on this screen. And I'm going to go, let's go find Hutchison. Okay, let's go find Hutch and the Cosmosphere. So this may take me a second. Okay, there's Wichita. There's Hutchison. Oh, there we go. Zoom in. Getting closer. So let's go see what the eclipse is going to look like the day of. All right, where am I at? I need to go north, don't I? Where am I? You think I know where I'm at in this town? Oh, now I see it. Okay, thank you. I was like, where am I? You go north here. Okay, so here's the Cosmosphere. So let's zoom in, and I'm just going to click basically right here in front of the door, okay, of the building. So when I do that, this little box pops up. I know it's kind of hard to see, and unfortunately, I can't make it bigger. I hate how they did that. But what this tells us is very helpful information. For one, it tells you when the eclipse is going to start, when the max eclipse is going to happen, and when it ends. Now, it is in UTC, so universal time. So unfortunately, you have to convert it into the proper time zone. But I have a handy little conversion chart that I'm going to link at the end that I use all the time because I can never remember how many hours you have to subtract and add and all that jazz. So here's the Cosmosphere in our parking lot where it says obscuration, 85%. That's pretty good, right? That's pretty good. But are you going to see totality? No, you're not. So 85% might be pretty good on a test, but 85% for a total eclipse, you fail. Okay, just going to put it out there. You fail. So you will see the partial eclipse. The sun will be obscured. The moon will cover it. But that video I showed you earlier of me in Roswell, that's about as dark as it's going to get. It will get it'll get darker-ish. It's a weird sensation on how to describe it. It just gets like faded. The light does a little bit. It's so weird how that happens. But that's about all it's going to do here, unfortunately. So if you have eclipse glasses, you'll be able to safely look at the sun and you'll see about 85% of it get covered. So that's good. That's a good thing. Don't get me wrong. Partial eclipses are cool. I've seen them before, but you want to get to totality. So where do you need to go? So let's zoom back out. Let me exit that little box right there. Again, for you to see the entire eclipse, let's go see the entire United States. There we go. You need to go somewhere within that little shadowed area. Okay. Now, you may notice there's a red line on each side, and then there's a blue line that passes through that. That is, the closer you get to that blue line, the longer you're going to see the eclipse. Okay. So for instance, you don't have to travel too far if you want to try to do it. It's on a Monday, so you have to take off work. Sorry, Joanne, I'm not going to be here. And so go to South Oklahoma, a good chunk of Arkansas, Missouri. So again, you don't have to travel too terribly far, but let's go zoom in. I'm just going to kind of click a random little spot here in Arkansas, right there as close as I can get to the line. Okay. Oop. Trying to touch the mouse. So it'll tell you a little bit more information because now we are in totality. So you'll see where it says it is 100% obscured. Okay, so totality will happen. And total solar eclipse, 4 minutes and 16 seconds. Okay, so pretty good amount of time. I had about 2.5 minutes for the last eclipse. So this is going to feel like an eternity for this one to happen. So wherever you choose to go, you can literally go down to the road that you want to go to. Like I said, this is just like Google Maps. So you can zoom in. Oops, this mouse is bouncing all over the place. You can zoom in and you can pick literally what road you want to be on. And you can it'll tell you what time the eclipse starts, how long it's going to last. And if you hover over the little things here. It'll give you that little animation there in the middle, so you'll know exactly what to expect. So, like I said, this is an amazing tool to be able to use, and they are being made for all the other eclipses, so very handy. So like I said, the closer you get to the blue line, the better. Sorry, this mouse is jumping all over the place. Now, let's travel out to, we had 4 minutes and 16 seconds. Let's travel out here closer to the red line. So there's the red line. I'm going to click right next to the red line. So we're still in totality, but now rather than 4 minutes and 16 seconds, we have what? 41 seconds. So you still will see totality, but not nearly as long. Okay, so make sure you're in that red line, those red lines. Otherwise, you will not see totality. And you would not believe how bright the sun still is, even when it is 99.999% covered. It's still going to be pretty bright. Okay, so again, I will have a link to this at the end so you can go visit it. Like I said, it is so helpful for all your planning of the eclipse. Okay. All right, I'm going to go back into my little presentation here. I'm going to make this full screen again. Yep. All right. So obviously, when you are viewing a solar eclipse, you want to be safe about it. Okay. So there are eclipse glasses. I'm sure you've all probably seen them before. I have a couple pairs of them here. We actually sell these here in the gift shop in the museum. So if you are needing a pair, run in there and grab you a pair. So most eclipse glasses are going to be like these little cardboard pieces, and they're much stronger than just a regular pair of sunglasses. The material that's in them is going to block out pretty much all of the light, not all of it, but pretty much all of it, and to be able to allow you to safely look at the sun. So there are also these that look more like sunglasses. I used these for the last annular eclipse, and they worked really well as well. They just have a little bit more sturdiness to them. So, like I said, we're selling them in the museum, in the gift shop, along with, I think Steve said he had some these little filters you could put over your camera, a little booklet that it kind of talks about the eclipse. So some really good information there. Now, you will probably getting closer to the eclipse hear about like fake, not proper solar glasses. Whenever you purchase a solar solar eclipse glasses, you'll want to look for the little ISO emblem there, and they will give you actual proper safety instructions on there. Because they apparently for the last total eclipse, there was people selling fake ones. I never personally saw them, but apparently they were out there. So get you some eclipse glasses so you can properly protect your eyes. Now, one other main thing that happens, or one big thing that happens during the eclipse is these things called shadow bands. These happen about 20 seconds before totality happens. I tried to photograph and film them before the last eclipse, but I didn't get a good shot of it. So basically what's happening here is that, here, let me just go ahead and play here. Oops, no. Spoiler alert, you saw my next slide. So what's happening here is if you look really closely on that sheet, you will kind of see some wispy little bands moving across it, okay? And that's basically a shadows of the atmosphere, of our atmosphere. Because right before totality happens, the sun is such a small little slither, such fine point of light that it's able to define our atmosphere, the gases in our atmosphere, and create a shadow of them on the ground. Okay, this is the only time you can see them is during a total eclipse. They're really hard to see. They're really hard to photograph for sure. But like I said, it kind of looks like a wavy mirage type of looking appearance, basically. So my next goal for the next eclipse is try to capture that. So definitely my next goal. All right. So obviously, if you're going to the eclipse, you need your eclipse snacks. You can't forget those. So get you some moon pies, some star crunches, all that jazz. If you plan to do this, you might want to go a couple weeks beforehand. For the 2017 eclipse, I tried like a couple days to go find moon pies. You couldn't find a moon pie anywhere in a 100-mile radius. They were sold out everywhere. So I don't remember what I got. I don't even think I could find eclipse gum on that day. Literally, they were sold out everywhere. So get your snacks, make sure you are all prepared. Now, like I said, I have all these helpful resources. These are the maps, links to the time conversion, the website. The thing at the bottom where it says that last link, that's the link to Javier's website where you can find maps for all the other upcoming eclipses. The next total solar eclipse after this upcoming one that's going to happen across the entire United States is not until August of 2045. So 21 years away. So if you miss this one, you got to wait a couple of years, or you got to travel somewhere else in the world, which, you know, if you have the means of doing that, go for it. There's one in 2027 that passes straight through Egypt. It will pass just south of Cairo, Egypt. I would love to go see that one. I don't know if it's going to happen, but that's a high one on my personal bucket list. Now, one other thing I wanted to show you guys before I have no idea what time it is, so sorry if I'm going over time, is there's a really handy app that is available on Androids and iPhones for being able to remember what you need to do during the eclipse. Because like I said earlier, when the eclipse happens, at least for me, your brain stops working. You forget what you're doing. And so I needed cues on reminding me what to do. You wouldn't think that was needed, but it definitely is. So it's an app called Solar Eclipse Timer. That's a little image of what it looks like. I do have some screenshots here and a couple of videos. So it's very handy for one, setting up exactly where you are going to be. And so you'll do that by selecting eclipse to time. This is a video, so I'll play it here. Let me go ahead and click that. And you can choose upcoming eclipses. Now I will let you know, I did have to pay for the one in April. It was like a couple dollars. So it will show you a list of some of the ones you can choose from. And then you will either input your exact latitude and longitude, or you can hit the find my GPS thing. Since I was doing this here, it was not finding it properly. So I just put a random GPS latitude and longitude for somewhere in Arkansas. So once you do that, you hit that calculate contact times, and it will tell you exactly when all the times happen for when the eclipse is going to start. So, and then once you hit that bottom thing, this is what will show. So it'll tell you exactly when first contact happens, meaning the moon starts to cover the sun, when second contact happens, and then when totality happens, and so forth. So it's a very, very helpful, handy app to use. Now, this other video that I have over here, I am going ahead and I'm going to start it. I am going to turn it down a little bit because it probably will end up being kind of loud. And I'm going to, this is a video of kind of showing you what to expect that the app will tell you to do, basically. So I'm going to skip it forward. Talk about that in a minute. So this is just a video kind of showing you what to expect. Again, it's giving you tips, including like helpful notifications of what to do. Glasses off. Remember to do that. If you don't take your glasses off, you won't see totality. Okay. Totality is the only time you can safely remove your glasses to view the sun. Okay. Don't forget to take them off. At that point in time, just like they said, observe for planets and stars. I believe Jupiter, Venus, Saturn, and Mars are all going to be visible fairly close to the sun that day. And so if you are in the path of totality, you will very likely probably get to see those when totality hits, which is just kind of weird to think that you're seeing the planets in the middle of the day. The eclipse does happen kind of high noon, 1 o'clock in the afternoon is like just shy of when the totality actually hits for your local time. And so it's going to be kind of high in the sky, give or take. So I recommend find you a comfy chair, sit in that chair and just enjoy it. okay? If you have the means to photograph it, but I promise you, you'll regret it if you sit there and you're fiddling with your camera the whole time and you miss the whole thing. My husband told me the other day, he's not touching a camera during the entire thing. He did that during the last eclipse and he missed some of it because he was messing with the camera and didn't get to enjoy this, for some people, once in a lifetime experience that they get to see. So grab your snacks, set in your chair. When totality happens, take your glasses off and just enjoy the almost 4.5 minutes that you're going to get of one of the most amazing sights that you will get to see. So I promise you, you won't regret it. Okay. I will leave this little guy up here for anybody who, like I said, if you want to take a picture of it. There is another little world clock app that I found that is helpful for the whole translating from UTC to local time. So there's a lot of other apps and stuff out there you can use, but these are the ones that I have found to be most helpful for me. I also included my email address down there. So if at any point anybody wants to reach out to me to be like, hey, I have a question or I need help with XYZ, I'd be more than happy to help out with any eclipse questions you may have. So there we have it. 80 days away from totality. Like I said, if you have plans to go see it, I wish you good luck, clear skies, and don't forget your snacks. Okay, those are important. Anybody have any questions kind of related to eclipses in general? Um, I've seen that that I even think these have an expiration date on them. Um, they're not expensive. I'd get you another pair. I mean, I probably just because, you only have one set of eyes. And I'd spend a couple dollars on protecting them. So, but yeah, I don't know the true accuracy of the expiration of those glasses, but I would go get you a new pair. Yeah, for sure. At the what? Nifty Nut House in Wichita. Oh, they got moon pies there. Okay, that's where you go to get your moon pies. Like seriously, you need your moon pies and your sun kissed. Yeah, you need your candy, 100%. So very important. Uh, anything else, Nick? Yep, they do happen at various times of the day. Um, Sometimes you will only get to see part of an eclipse. Sometimes you won't get to see any of it at all. So yeah, we just got lucky enough that this is kind of in the middle of the day. The 2017 eclipse was a little earlier in the morning. I don't remember exactly what time it was. It was like 10 or 11 o'clock, something like that. Um, so yeah, sometimes it will happen first thing in the morning, right at sunset. So yeah, it definitely, and then what's cool about that is when you get a perspective, I would love to see a total eclipse when it's like about to set, the sun's about to set. I think that would be amazing to be able to see that one. So, yeah, good question. Yes. Mm-hmm. Sure. Oh, that's good. But yes, that's a very good thing. You can take a piece of paper, whatever you have handy. I know a lot of people will get like their spaghetti strainer from their kitchen. And when partial eclipse happens up to totality, you can hold it out and you'll see whatever, the shape of the sun. So yeah, like I said, if you don't have a spaghetti strainer near you, just find a piece of paper and poke a hole in it and you'll be able to do that. So in case you don't have the solar glasses, then that's another way to safely look at the sun. Michelle. Mm-hmm. Mm-hmm. Yep. Yep. So, like I said, as soon as the partial starts, um, you'll be able to see it up until the max eclipse. Like I said, it'll only be 85% full, but yeah, you'll be able to do that experiment. And like I said, the light will start to dim. It will definitely feel, it's just it's hardest thing to describe of what it feels like. It's just like someone's putting sunglasses over the sun because that's basically what they're doing, or what the moon is doing. So yeah, it's a very, just, I won't say eerie, just very interesting sensation that you get to experience. So yes, Jim. Um, that's a great question. We have not discussed that. That will be a Michelle question. I'm sure. Bus tour to Arkansas, I am down. But just like I tell everybody who asks me, because I honestly, I don't know where I'm going yet. If you would have asked me a couple years ago, I was going to go to Arkansas into the Ouachita National Forest that they have there. Um, but here in the past handful of months, I've been debating on maybe going farther south into Texas, just because it's April and you never know what the weather's going to do here in the Midwest. So you have to be prepared or be ready to accept the fact that you may not see it. Originally for 2017, I was going to go to Nebraska. And then I knew the weather was going to be bad. And so we just booked it west. And then we went north and we landed up in the middle of nowhere, Wyoming, in a field with 100,000 people. So you never know where the road's going to take you for it. But yeah, as far as an event here at the Cosmosphere, we have not discussed anything like that yet, but oh, right. So yes. So be on the lookout if we do plan anything. I know it'll go on social media and all that jazz, but I know a lot of people want to go to Totality. And like I said, if you have the means to do it, do it. You won't get this chance again for a very long time or ever. You never know. 80 days away, make it happen. All right. Any other questions? Does anybody plan to go to Totality? Okay, got some plans. All right, very good, very good. John does. So yeah, like I said, you don't have to travel too far. I don't know how far away, what, 6, 8 hours down in that area between Oklahoma, Arkansas area. So not too bad. Totally worth it. Just don't forget your snacks. Road trip snacks. All righty. Well, if there is no other questions, thank you guys so much for letting me kind of talk about the eclipse. Like I said, reach out to me if you have any other questions or any other helpful tips or anything like that. Don't forget your glasses in the gift shop. Like I said, very important. Yes, sir. Yep, yep. We can get all those up there. Like I said, they are super helpful. When I found the Eclipse map for the 2017 eclipse, I was like, this is the coolest thing in the world. It is so helpful when planning where you want to go. So yeah, very, very helpful. And then the NASA Eclipse website, it will literally list every eclipse from now until like 1,000 years from now. So plan eclipses for the rest of your life. Not only with solar eclipses, but lunar eclipses as well. So a very, very helpful tip and information. All right. Well, again, thank you for letting me, talk about my experience, and hopefully you guys learn something and kind of know what to look for and how to prepare differently or better for the upcoming eclipse. All right. Well, thank you very much.